Hello and welcome to class. We are still on the concept of binary operation, problems of binary operation, and we are confronted with the problem to say let Z be the set of all integers. Is this operation a binary on the set of integer if whenever this operation comes in between two elements A and B that belongs to the set of all integer, and if this becomes a root of the product between A and B. Let's see if the resultant of this mathematical expression will give us an element in Z. Now we know the set of all integer, if I want to make a listing, it is -3, -2, -1, 0, 1, 2, 3, and there's an omission of elements, and there's also omission of elements of negative integers. Here there is omission of positive integer, but it goes to infinity. Now we are asked to show if or whether this particular operation is a binary on Z. Now this operation becomes a binary operation on Z if only it can drive the pair of every pair in this particular concept, every pair, every A and B element of Z, if it can drive the pair to an element C, where C belongs to Z, and we know A and B also belongs to Z. Now, and we know that this particular thing can be written as this becomes a binary operation on this if whenever it comes in between A and B, the resultant of this action gives us an element C, where C belongs to Z. Whenever these operations satisfy this particular concept, we see that this becomes a binary operation on Z. Now, let's take up to a pair of elements in this. Now let's call 2 and 2. This is a pair. This first element belongs to Z, and the second element also belongs to Z. Now let's see if whenever this particular concept is coming in between them, let's see the resultant of the effect. Now you see 2, whenever this operation comes in between 2 or is being interposed between 2 and 2, what happens? When you compare with the given expression, you see A here happens to be 2 and B here happens to be 2 also. So the result of this with respect to the given function becomes the root of 2 times 2, which is going to give us the root of 4. And we know the root of 4 is equal to 2, which also belongs to the set of all integers. But let's check also if this particular thing, the pair of elements in Z, if for all pair, if this particular concept could drive it to C, where C belongs to the element in Z. Now let's see again. If we take an element from here, let's say 1. It's a 1 and -1. You see the first element here belongs to Z, and the second element here belongs to the set of all integer. Let's see if whenever this particular operation is interposed between 1 and -1, let's see the results of the effect. Now 1 on -1 with respect to the given function, here A becomes 1 and B becomes -1. What happened? We have the square root of A times the square root of what? B. So here is A, we have 1 multiplying -1. What happened? We have -1, and -1 is an imaginary number. It's an imaginary number, so we call it I from the concept of complex analysis. We call it from the concept of complex number. We call this I square root of minus 1, which is imaginary number. We call it imaginary number. And you see that I itself is not an element of Z. So what happened? You see that this particular operation failed to satisfy this. It fails to satisfy this, which we say that it becomes a binary operation if it could drive the pair of elements in Z to an element in Z. If it can drive this, the resultant of this, whenever it comes in between, will give us C, where C belongs to an element in Z. Now, again, if I come up with two, let's say 2 and 3, the first element belongs to the set of integer here, and the second element also belongs to the set of integer Z. Now, let's see if this particular operation comes in between, what happens with respect to the given expression. We have this to be the square root. A becomes 2 and B becomes 3. We have 2 times 3, which gives us square root of what? 6. And this thing will give us a decimal value. It's going to give us a decimal value. A decimal value, and decimal value are never found in the set of integer. Hence, what you have to say, you see that this operation is not a binary. Is not a binary on the set of integer. This is not a binary on the set of all